I thought I would give a quick overview of our environmental monitoring system for our very small data closet, particularly given that we've been having AC issues recently, as you can probably see in this graph. We have our set point set to 70 degrees. When it's warm outside and the AC is running, like today, it generally maintains right around 70 when everything's operational and working correctly. When it's a little bit colder outside, it actually seems to maintain about 68 for some reason, even though the set point is 70. And it's just how our AC works, it's a quirk. But recently, we've been having our AC drop out, and we've been having problems with it, so when that happens, you can see these very large spikes in our graph. This hit a maximum of 82 degrees earlier in the week, and this is the last week. This is the last 24 hours. It's a bash script that actually interprets syslog data, and it outputs to our Nginx server, I think, every 5 minutes, but it can be up to 15 minutes out of date. You can see here this was last updated at 11:05 p.m., and as of this recording, it's actually 11:20 right now. Currently, it's saying it's 67.4 degrees in our data closet. We also have a water sensor that reads open when everything's good. If it's tripped with water, it will read closed. And we also have a special AC condensate overflow switch that I wired up, and we'll get to that in a second. And this reads closed and everything is fine, or open when the pump isn't running and the water's actually risen to a level that trips the condensate overflow switch, which turns our AC off, and that's a danger condition. On Friday, we wired up a backup AC system so that if our main AC fails, it will kick in and it will at least keep things from getting too toasty inside of our little data center. Here, it actually happens. So our trigger condition is 75 degrees for 5 minutes, and our backup AC will kick in. So if we go here, right here, you can see this is about 75 degrees, right around, I don't know. This really looks like it should be about 440, 445 is about when it should have kicked in, and it would have kicked out. So again, it takes 5 minutes for it to kick off too. So after it drops below 75, so 75, then add 5 minutes. So it'd be a little bit after 6, and then it probably kicked back in right around here. Well, actually kicked in right there. But the trigger would have been initially set, and the 5 minutes started counting right here. So that's about 6:20 maybe, 6:15, and then kick back out again. It looks like right after 7. And the interesting thing to note is when our main AC wasn't functioning properly, you see this, the steepness of this graph right here, how quickly our temperature is rising. When our backup AC kicked in, that slope is quite different. If you try to line that line up, it would be like right here versus up and down, almost vertical. So our backup AC is definitely effective. It helps a lot, and it keeps our servers from melting down. I'll show you how I did this here in a second. We use this IoT relay. I assume IoT is Internet of Things. It's a relay. It's a high-power relay, and it's only $15 on Amazon. It can be controlled by either a low or moderate voltage DC source, or by a pretty much moderate to wall outlet AC voltage. And when it's triggered, the normally on side will go to normally off, and the normally off side will go to normally on. We have our AC unit plugged into the normally off side, and when our environmental monitor triggers it, it will turn on. The one thing to note about this is we're going to switch over to our environmental monitor in a second, and you'll see that you need to supply some voltage to actually turn this relay on, and our environmental monitor, all it has is a relay output, so it doesn't actually give you any voltage. You have to supply that voltage yourself. And I came up with a little bit of a creative solution for that. The environmental monitor that we have is this NTI Enviromux-mini LXO. It looks like this. And I highly recommend this unit. It will bring in, we have a temperature and humidity sensor. It's a combination sensor, and it hangs at the back of our rack. It does a very, very good job, as you can probably tell from here. It seems to be pretty accurate. I don't have the humidity charted here, but we do bring humidity into our unit itself. It also has up to 5 digital inputs, and it also has an output relay. Currently, we're using 2 of these digital inputs and also the output relay. The first digital input that we're using is for a water sensor. It's a rope type sensor that hangs out at the very bottom of our rack, and if we detect water there, it will get tripped. And then our second digital input is a custom built box that just reads the current status of our AC condensate overflow switch. And it keeps it electrically isolated from our NTI environmental monitor and from the AC system itself. Then our output relay here is connected to this. But what I had to do to get voltage in, and I'm controlling it with 5 volts from USB, is I either needed a wall wart that would provide that voltage, or because I was trying to keep it as compact as possible, what I decided to try and do is actually use one of these USB ports in the back to provide that power. And it actually works perfectly fine. I don't think it's designed for it, but it works perfectly fine. So what I did is I just took a USB cable, I sacrificed a good USB cable, I cut the end off, and I pulled voltage directly from this port, and I have it wire nutted to, I think, the common relay input on this box, and then the normally open side runs over to this right here. So it receives 5 volts DC to trigger this relay when triggered. This particular unit actually does some really cool things. It can actually alert you with a variety of different methods, either via email. It can SMS you if you have all the cell phone components for it. It can send you SNMP traps. It can give you web alerts. It can give you a voice phone call. And it can alert you via Syslog as well. It can also interface, I think this is what the USB ports are for, by the way. It can also interface with an IP camera. And you can wire in contacts, like door contacts, to one of these digital inputs. And every time the door opens or closes, it can take a picture of whatever's in front of the door. So presumably that would be a person, and it can actually send you a picture along with the alert when something happens. It can also be used, of course, if you have an IP camera in your data center and something goes very far out of range, or the water sensor is tripped. You can take a picture and email it to you. So at this point, when you go to your phone because you're being notified that something is out of whack, you can verify whether or not the data center is actually flooded, or if it's on fire or something like that, so that it's not like the boy who cried wolf scenario. We can tell when there's an actual verifiable disaster versus maybe it's not such a big deal and it can wait. Without further ado, we're going to take you over to the actual dashboard for our NTI environmental monitor. You can tell this guy's been up for 330 days. It's been quite reliable. It does a great job. I didn't fill in all the information, and I don't take advantage of all the features this environmental monitor has to offer, but the features that we are currently using have proven to be invaluable. Right now we can see that our server room temperature is a nice 67.6 degrees Fahrenheit, and the humidity is 45%. We also have those 2 digital inputs, and you can see they're labeled 1 through 5. We're using 1 and 2 for the water sensor and the AC overflow. And we can also configure the status for being what the normal status is, basically. So in this case, open is normal, and in the case of the AC overflow switch, closed is normal. This is all configurable. We also have the output relay wired to our backup AC, and then it also has this very cool functionality called smart alerting that allows us to trigger the output relay or perform some other action based on a combination of actions. We can go there right now. The first thing to do to be able to set up, to be able to set up a smart alert is define events. So we have an event defined here that is for when the server room temperature is above 75 degrees Fahrenheit. And we can see it's not triggered right now. It's currently 67.7. But when this goes above 75, this will say triggered. Over here we have another event, and this is for the server room AC overflow switch. If this ever goes to open instead of closed, that means our condensate pump is not running and it has disabled our main AC, so we want our backup AC to kick in instead. Hopefully this one never trips, but it's nice to have. You can click into each of these events and you can see exactly how they're configured. And in this case, it has to be 75 degrees, and it has to be 75 degrees for at least 30 seconds. We also set the auto acknowledge so that when this decreases below 75 degrees, it doesn't keep reading triggered, it will automatically reset itself. We can also tell it to send us a Syslog alert or an SNMP alert or an email alert or whatever. And of course the IP camera captured email, like I was just describing, when this event fires. We're going to go to Smart Alerts now, and this is where we reference our events. I called this event, or the Smart Alert, Enable Backup AC, because that's exactly what it does. And in this particular case, we're using an OR, and we want this to happen if the server room temperature is greater than 75 degrees, or if the server room AC overflow switch trips. You can also configure AND events, so maybe we need it to be 75 degrees and the AC not to be running and the AC overflow switch to be tripped. I don't know. But it gives you a lot of flexibility and a lot of power to be able to use this environmental monitor. We configure this to use the logical function of OR, just like so. And we set a delay of 5 minutes, and this keeps our AC, our backup AC, from flipping on and off very rapidly because of a small change in temperature. So, as I was describing earlier, here, it has to be above 75 for 5 minutes, and then the AC kicks in, which is this little dip right here, this little anomaly. You can see it happens right there too when it kicks in. And then it also takes 5 minutes for it to kick out. So after we drop below 75, it's another 5 minutes before the backup AC goes off. We also have a Smart Alert notification. So it notifies us when it returns back to a normal state. And it also has an auto acknowledge set as well. And this one actually does go to Syslog, which I will show you in about 2 seconds. And after every 30 minutes, it continually notifies us, and you can see this as well inside of our syslog. So here I grepped our syslog. It just goes to our var log messages, main syslog. I should probably do a better job cleaning this up, but for right now, you can see how this works. On April 29th, this was just a test, but today it actually kicked in twice. So the first time it kicked in, you can see it triggered at 4:49. And then it cleared at 6:02. Then it tripped again at 6:23, and then it cleared again at 7:13. Just like it says here, every 30 minutes it notifies us. So it says still triggered. We can see something is still going on, so every 30 minutes it triggers. So 19:49, 30-minute difference, 19:49, 30-minute difference. It does exactly what it's supposed to do every single time, and I love this unit for it. Finally, we have our Smart Alert command, and we have the associated output relay, which is our backup AC, and it sets it to active when alerted and inactive when the alert returns to normal. So this turns our AC on, and then it turns it back off. All of this, again, works extremely well. You can set different users to different roles. So if you have a sysadmin, maybe you have physical security, maybe you have your CIO or the president, and they want to be notified about very, very major things, but all the other noise they don't want to get notified about. This is all configurable to allow you to do that. If we go to edit, for instance, here, there are 8 different groups you can assign events to and also employees to. The employees can be a member of multiple groups, and this is how our data logging is actually configured. In this case, we have our server room temperature is logged every 10 minutes, and it gets added to our data log as group 1. When we go to our log and our log settings, you can see that we have group 2 and group 1. Group 1 is set to syslog, as is group 2, but we can again configure users for each of these groups so that one user may only receive group 1 alerts while another user may receive group 2 and group 1 alerts, or just group 2 alerts. It all works fantastically well, and I highly recommend picking one of these up. I think that about concludes this overview. Hopefully you learned something and maybe you'll actually go ahead and buy one. I'm very, very happy with both this relay unit and this environmental monitor. NTI has been fantastic to work with, and their products have been incredibly reliable and robust. I highly recommend buying them.